Proofs by induction don't necessarily have to involve just proving things about formulas regarding integers. For example, let's say that we have a class of n students. And the claim is that there are n times n minus 1 over 2 distinct pairs of students. Okay, so you have a class of n students. The claim is that there are n times n minus 1 over 2 just different pairs of students. A pair of students is just, a grouping of two students together. So let's let P of n be the predicate that in a class of n students, there are n times n minus 1 over 2 different pairs. So just the same as the problem. Again, not difficult to write down the predicate that we need that we'll be using when we invoke the inductive hypothesis. So we want to prove that for all n, I guess, greater than or equal to 1, P of n is true. And what's the base case? Well, it's P of 1. What is P of 1? P of 1 is in a class of one student, there are 1 times 1 minus 1, which is 0, over 2 different pairs. So in a class of one student, there are 0 different pairs. That makes sense. If there's only one student, then there are 0 pairs of students because there's only one student. Just for the sake of example, let's look at P2, even though this would suffice for the base case. But let's look at P2 just to build some intuition. So in a class of 2 students, there are 2 times 1 divided by 2 different pairs. That's in a class of 2 students, there is 1 different pair. Well, yeah, that makes sense. If you have 2 students, there's 1 pair, those 2 students, that's the only pair of students that you can make. So our base case, we only had to do P of 1 here. I did P of 2 just to build some intuition, but our base case is finished. Okay, now I'm going to carry out the inductive step, so let me move this up a little bit. Good. Okay, so we want to prove that for all n, P of n implies P of n plus 1. So we can assume that P of n is true, and we need to prove that P of n plus 1 is true. Okay, so I guess, yeah, step 1, P of n is true. Step 2, we need to prove the class of n plus 1 students has n plus 1 times n over 2 different pairs. Okay, well, how do we prove something like this? So we're given a class of n plus 1 students. And this is what we need to prove. Right here. We need to prove. That's what we need to prove. And we have this class of n plus 1 students. So, up a little bit. Imagine each one of these dots is a student. Okay, so imagine I've drawn n plus 1 of them. Now I'm going to pick one special student right here, this student. We'll call this student John. I don't know. There's John. And so here are the other n students, right? One student, here's the other n students. Now, how many different pairs are there of students among these n students, not including John? So how many pairs not including John? Well, if they don't include John, it means how many different pairs are there of these n students? Well, we assume that P of n is true, and P of n says that in a class of n students, there are n times n minus 1 over 2 different pairs. Okay, so how many pairs are there not including John? This is where we use the inductive hypothesis. Because we assume P of n was true, it tells us there are n times n minus 1 over 2 pairs because this is n students. Okay, how many pairs of students did we leave out by not counting John? Well, John could have paired up with this student, or 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 this student. We left out n pairs of students. Right? John could have been could have formed a pair with any one of these n students, and so the total number of pairs of students is equal to n times n minus 1 over 2. That's all the pairs that you form excluding John, plus all the pairs that John could have formed with these n students. That's n. This equals n times n minus 1 over 2 plus 2n. I'm putting it over a common denominator. And if you simplify this one step further, this is equal to n plus 1 times n over 2. So, given a class of n plus 1 students, we proved that there are n plus 1 times n over 2 different pairs of students. But that's exactly what we needed to prove up here, that given a class of n plus 1 students, there are n plus 1 times n over 2 different pairs. So this completes the inductive step and the proof.